AOS के PM ई विद्या चैनल में आप सभी का स्वागत है। मैं आंचल गोस्वामी, AO ICT NIOS। आज हम टॉपिक डिस्कस करेंगे बेसिक्स ऑफ डेटा कम्युनिकेशन एंड कंप्यूटर नेटवर्किंग। हमारे वोकेशनल कोर्स कंप्यूटर एंड ऑफिस एप्लीकेशंस का ये सेकेंड चैप्टर है। आज हम इसमें पढ़ेंगे कि डेटा कम्युनिकेशन और नेटवर्किंग के कॉन्सेप्ट्स को। सो फर्स्ट टॉपिक इज डेटा कम्युनिकेशन। व्हाट इज कम्युनिकेशन? As we all know, communication is exchange of thoughts and thoughts from one person to another person. So when we talk about communication, it is sharing information. Sharing can be local, face to face, or remote, or telecommunication. In telecommunication, the word tele refers to far. This means the communication is distance communication. And data refers to information presented in whatever form is agreed upon the parties creating and using the data. So data refers to the information which is processed according to some need of the users. According to some requirement, we process the information and we get some part of the information. We call it as data. So data communication is when we are transferring data from one sender to another receiver at some place. So data communications are the exchange of data between two devices via some form of transmission medium such as a wire cable. So transmission medium can be anything. It can be a wireless medium or it can be a wired medium. In wired medium also we have different types of cables, like we have coaxial cable, twisted pair cable, and according to the requirements of the network we choose what kind of cable do we need. In wireless medium we use radio waves, microwaves, like we use in our cellular phones, in our wireless communication through mobile phones, through other devices. We use wireless medium to send messages from one end to another end. Next is effectiveness of data communications. We will discuss that how communication can be effective. What are the factors through which we can decide that communication is happening very effectively? So first concept is delivery, that the message should deliver to the right destination. It should not reach to some another destination. So data must be received only by the intended device or user for which it has to be sent. Obviously, when data is not sent to the accurate device, it is sent to some another device, then it means that we can say that there is some fraud, there is some insecurity in our communication network. Next is accuracy. Accuracy means data should be received at the receiver in accurate form, in exact form. There should be no error in the data from the sender or during the transmission. Error can be there in form of like some extra packet has to be traveled, some packet has been truncated from the data. So this should not happen. If data is received in some other form at the receiver, it would not be received in the proper form, in proper exact format. It will not be accurate to process that data at receiving end. Next is timeliness. Obviously, the message should reach the destination in the stipulated time. For every packet, it should reach at time, because when transmission happens, it happens from packet to packet, and all the packets have to reach in the same sequence as they have been transferred from the sender. So every packet has to reach there timely so that the sequence will not be disturbed at receiving end. So timeliness is important. The system must deliver data in a timely manner. Data delivered later are obviously useless. We can also consider an example of, like, we use a connectionless connection in a multimedia communication, like when some video message or audio message is delivered through some channels, then if it is not done timely, if it is not sent timely in the right sequence, in the right order of frames, it will not be delivered in the manner which it is intended to be. Next is jitter. Jitter is called the variation in the packet arrival time. It is the uneven delay in the delivery of audio or video packets. So it should not happen. There should be least jitter in the transmission of data packets. Next is basic concepts in a data communication system. And what are the basic things basic parameters which are required to be assessed in a data communication? Bandwidth, first is bandwidth. Bandwidth is the maximum data which can be propagated from a channel per unit time. That it is the capacity of the channel that it can transmit this much amount of data. So amount of data that can be transferred from one point to another in a certain time period. It is called bandwidth. It is measured in bits per second. Sorry. Next is attenuation. Attenuation is loss of power in a signal as it travels from the sending device to the receiving device. Sometimes what happens that during the propagation the signal loses its power, like it gets depleted in between the propagation, like there can be multiple factors, like some reasons of cable, some reasons of wired or wireless medium, because of the medium, because of some other factors, the data is during traveling it loses its power, it loses the voltage power of the signal, we can say. So loss of power should not be there. So we will we will judge a communication network in the terms of how much attenuation, how least attenuation can be there. Next is protocols. Protocols are very important, like when we have to communicate. Sender has to send some message, receiver has to receive some message. So there should be kind of protocols which are run at both the ends in the similar manner. There should be some rules through which sender should send the message and such rules that receiver would receive the message. Like we communicate with each other, some people with different languages, they communicate each other. So while sending data, it will follow some kind of rules, some kind of steps, and while translating there would be some kind of steps, and when it is translated reverse in another language, it will be going through different types of steps. So there should be protocols who will define these rules. Okay, this rule will define this process, and accordingly data will go through those processes. Like when data is at application layer, we can say when data is at software layer, it is in form of software. It will be divided into some packets. Then there will be some information will be attached to those packets. At the basic level, at the physical level, it will be transmitted in form of signals. So at that point, there should be some mechanism, there should be some flow control mechanism, error control mechanism, and when the process will go at the receiver end, there should be reverse process with the same kind of rules. So these rules at different steps, both at the sender, at the receiver, these are called protocols. So we can say rules that govern data communication, including error detection, message length, transmission speed, etc. Also correction and flow of the message, sequence of the message, these are all governed by different protocols at different steps at both the ends, sender and receiver. Next is components of data communication. In any communication, at any instance we can say we will have 5 main components. First would be the sender. Next will be the receiver. Communication will be happening between the two, sender and the receiver. In between we will have a medium. Medium will be either can be wireless or can be wired. And secondly will be the message. Obviously the message will be sent from sender to receiver. And thirdly protocol. We can see in the diagram that there are some rules we can call protocol at sender end and some rules at the receiver end. So protocol is a set of rules that governs data communications. It represents an agreement between the communicating devices. Okay, I will follow these rules. You follow these rules in reverse manner. Without a protocol, two devices may be connected but not communicating. So communication is receiving of messages in the correct form, timely, without loss of any signal. So this process needs to be governed by protocols. Next is data flow. Data flow can be different manner it can follow. There can be different kind of connection between sender and receiver. So we can let's consider that there is a wire between them and they are connected. So either It can happen simplex, half duplex and full duplex. The difference between these is when there is only one direction of data available, like message can go from one direction to another direction. There is only one path, then it is called simplex mode of communication. In half duplex mode of communication, message can be sent from this one direction to another, and at second interval, second time, it can be sent one from second station to first station. But at one time, at a point of time, data can travel either this way or that way. At same time, it cannot be communicated. It is not available for both sides of communication. So half duplex is when it is happening at different time intervals. In full duplex mode, direction of data all the time is available. All the time, station 1 can send messages to station 2 and station 2 can send messages to station 1. What is network? So network, we already know that network is connection of devices when different devices are connected with each other, and there is a complete system of connections between different devices, different computer systems. We can call them nodes. Every connected device in a network is called node, and these are connected through different mediums, and mediums can be wireless or wired. So a network is a set of devices connected by communication links. A node can be a computer, printer or any other device capable of sending or receiving data generated by other nodes on the network. Obviously, the device can be able to communicate, and the channel or the transmission medium, it has to be, it should be capable of sending messages from one medium to another. And a link can be a cable. It can be a cable, optical fiber or wireless medium carrying information. What are the criteria of a network? So what are the features we can say of a network? So performance, reliability and security. We will see them one by one. First is performance. So performance of network depends upon network elements, and it is measured in terms of delay and throughput. So throughput is when we count how much of the data is sent or communicated from one node to another in a specific unit of time. That how many packets, or we can say how much data in bits or in any unit we can measure it. It will transfer in how many time, how much data was transferred. We can also measure the performance in terms of delay. Delay we call propagation delay. In a medium, whether wireless or wired, there is some propagation delay because message has to travel, the signal has to travel. It takes some time for the transmission, so this we call delay. So for a good performance in a network, there should be minimum delay and maximum throughput. So a high efficiency network will have high throughput and minimum delay. Reliability. Reliability is like how can we say the system is reliable? We have to say that if system fails, then what is the alternative we have, and what is the failure rate of network components. Failure rate means that how often the transmission cables can generate errors. There can be how can the different nodes can vary the message, could not carry the message. So these kind of things will come in reliability. So it is measured in terms of availability and robustness of the system. Next and very important is security. Security is data protection against corruption, loss of data due to errors, malicious uses. As we are all aware nowadays that cyber security is also one of the very concerned issues in communication systems, that our messages should not be occupied, should not be altered by any malicious user in between the transmission. Any unauthorized access, any unauthenticated access should not happen at the system side, at the node side. So security of the network system is very important, that it should be reliable, that any user can trust the system, that it has accompanied with most of the secure protocols. And type of connection, what type of connection is there in the network, that whether there is point to point connection or multi-point connection. In point to point connection, every system is connected with another system. Like if one system has to connect with another system, there is a direct link between both of them. And in multi-point, there are multiple recipients of a single transmission. It is analogous to a bus topology, where we have a simple main transmission cable and many systems are connected to that cable, and ultimately any device can send message to another device through the cable, through the connections through the cable. In point to point, all devices are connected to each other through different cable. And next is physical topology. So when we consider a network, we consider how the systems, how the networks, how the nodes are connected to each other, in what form, in what we can say what method they are connected. Like they are connected in star system, they are connected in ring system, or they are connected in mesh system. These are different types of topologies we will discuss further. And what is the type of transmission? Unicast, multicast, or broadcast. In multicast, a system can send messages at the same time to multiple systems. In unicast, it can send message to a single system, and in broadcast, it can send message to all the nodes in the system. We can say physical structure. If we talk about the type of connection, physical structure कैसा होता है? Point to point में we can, जैसे अभी हमने discuss किया कि between every workstations, every pair of workstations, there is a direct link, either through wired medium or through wireless medium. In multi-point, there is a main link and different systems are connected to that link, and one workstation can communicate to another workstation through the path going through the link. When we talk about topologies, topologies are the methodologies, or we can say the pattern in which the systems are connected within a communication network. So first is mesh topology, star topology, bus topology, and ring topology. In bus topology, all the devices are connected to a central cable called bus or backbone of the network. The computers are attached through the bus. The ends of the buses are closed with a terminator, and the terminators are used to absorb signals. Advantages of a bus topology. So it is easy to install and configure, very easy. If we have to connect some another system, we can just add that system into the bus. It is inexpensive and it can be easily extended. Next is disadvantages. So performance decreases, weak signals, and difficult troubleshooting. If there is not proper communication happening, it is difficult to identify that from which node errors are happening. Next is star topology. In star topology, all the devices are connected to a central hub. Sorry. So nodes communicate across the network by passing data through hub or switch. So all the systems are connected to this hub. Advantages of star topology is easy to install and reconfigure. So when we have to connect some another system, it can be easily extended. We have just to connect that system to the hub. And no disruptions to the network when connecting or removing devices. In bus topology and in star topology, in both systems, we can connect or remove a system from the network, and it will not create any disturbance for other systems. It is robust, and fault identification isolation is easy in star topology. So what are the disadvantages? Disadvantages: if hub fails, then entire network fails, because every communication is happening through hub. Hub is responsible to forward the messages coming from one area, one path, and forwarding them to another path. So every communication happens. If two systems have to communicate, they will communicate through hub. So if hub fails, then no system can connect to the network. So there is a dependency on hub. So, and also it requires more cables, and it may require a device to rebroadcast signals across the network. Next topology is ring topology. In ring topology, systems are connected in a form of ring. So all the devices are connected to one another in the shape of a circle, and which system will transfer the signal, which system will send the signal on the bus, or we can say on the ring, it is decided by a token, and each device is connected directly or to other devices, one on either side of it. The token, the availability of token decides that which system can send a message to the bus. Advantages of ring topology: it provides an orderly network in which every device has access to the token and can transmit. So when the message sends a message, it releases the token on the network, and to which system it is allotted, then it is available for sending the messages, and it performs well under a heavy load. Disadvantages: failure of one computer can affect the whole network because they are connected in the shape of a circle. So even one system fails, then other systems cannot connect to any other. The ring, we can say, the ring is torn, and it is difficult to troubleshoot to find that which system from which system disturbance is occurring. And malfunctioning workstations and cables affect entire network because they are connected in a ring. So if any system is working slowly, it will it will make the entire communication system slow because there is dependency on the speed of each other to transmit the signals. Next is mesh topology. In mesh topology, there is a point-to-point connection among all the nodes available in the network. So each host has its connections to all other basic hosts. A message is sent directly. There is direct communication from one system to another system. So if any one system fails, that doesn't mean that any disturbance will happen in the network. There is point-to-point connection among all other nodes also. Advantages: it enhances for error tolerance provided by redundant links. So it is less prone to errors, and it is easy to troubleshoot. Obviously, we can identify that which link is not working properly, and we can troubleshoot that which device is not working properly. Disadvantages: it is difficult to install and maintain and expensive because it needs more number of cables, more number of connections, and it is little complex to handle. So therefore it is little expensive also. Last is tree topology. In tree topology, the systems are connected in the form of a tree. The tree topology is a type of network topology that resembles a tree. There is one central node called the trunk, and each node is connected to the central node through the single path. So we can see like it is a combination of star and bus topology. If for a single bus we have different hubs and two different hubs. For single hub there are multiple systems connected, to another hub there are multiple systems connected, and the hubs are connected on a single cable like bus topology. Advantages of tree topology: it is scalable. We can connect systems to hub, and if capacity of one hub reaches its highest point, we can add systems to another hub. And there are point-to-point connection of devices. Having different levels of the network makes it more manageable and hence easier for detection and isolation. Disadvantages: maintenance of the network may be an issue when the network spans a great area. And since it is a variation of bus topology, if the backbone fails, then entire network is crippled. If a hub fails, then the systems connected to that particular hub, that network fail, and if the bus fails, if the cable fails, then entire system fails. Last is hybrid topology. In hybrid topology, we can have combination of different topologies. As you can see in this presentation, that hybrid networks use a combination of any two or more topologies. In this topology, we have a star backbone with 3 bus networks. In tree topology, we saw that there was a backbone of bus topology and different hubs were connected. Here we can see the reverse of it. There is a hub, and to hub there are 3 buses and systems are connected on those buses using a bus topology. So these were the topologies, that in what pattern the systems are connected in a communication network. Next we will discuss that what are the categories of networks. Like we have communication systems across the network, across a single building, or across a medium ranged building. So on this classification, networks are divided into three categories: LANs, MANs and WANs. LAN stands for local area networks, and MAN stands for metropolitan area networks, and WAN stand for wide area networks. We'll see it one by one. Local area networks, these are networks which are spanned through short distances. We can say within a building, within 2 or 3 buildings. So there is a small network. They are like in a single building we have suppose 100 systems. These are connected to each other. We can say we have created a local area network, and it is designed to provide local interconnectivity. In metropolitan area network, it is there is connectivity provided to a little larger area, and in wide area networks there are long distances from countries to countries, from states to states. So we can consider them as wide area networks. So in local area network, a network that connects a group of computers in a small geographical area. Characteristics of a LAN: data transfer rate is generally high. They range from 100 Mbps to 1000 Mbps, and inexpensive medium of transmission, high degree of interconnection between computers, contained in one office or building. Organizations often have several LANs. So obviously when communication is in a very short range, short area, then we can explore all of the benefits of the system. Data transfer rate will be high because signal has to travel a shorter distance, and there will be no attenuation, not much delay in the signal. So we will achieve good throughput, good efficiency in the network. Next is metropolitan area networks, MANs. In this, the communication infrastructures that have been developed in and around large cities. When we say a city is spanned by a network, we can say it is a MAN. It is larger than a MAN and smaller than a WAN. So there are little expensive equipments required to connect systems from one building to another city. They are intermediate devices. We will see later that what kind of devices like routers, gateways, hubs, bridges, these are required to like we cannot connect one system to another system which is directly through a transmission cable which is some 1000 meters away. We have to insert some network devices for that. And data rates are moderate to high. Mostly used mediums are optical fiber, which are very high speed connective medium, and moderate error rates are there. We'll discuss it later after a short break. Thank you. मेरा गला बीच बीच में सुन.
प्रकाशित करने राहों को आलोकित करने, जीवन ये प्रकाशित करने राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, अपना दीपक स्वयं बने, हम अपना जीवन ये प्रकाशित करने राहों को आलोकित करने। धन साधन समय की सीमा से विद्यालय जो पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो। कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो। मित्रों हम पढ़े और जागे मंजिल आने की ध्वनि सुने हम अपना जीवन स्वयं बने हम अपना रास्ता स्वयं चुने। जीवन ये प्रकाशित करने राहों को आलोकित करने। राष्ट्रीय मुक्त विद्यालय का है द्वार खुला सबकी खातिर।
शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर
शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर दुनिया में इसके केंद्र बात कोई मन चाहा केंद्र चुने हम अपना जीवन स्वयं बने हम अपना रास्ता स्वयं चुने। कोई मन चाहा केंद्र चुने स्वयं बने हम
ब्रेक के बाद फिर से आप सभी का स्वागत है। हमने पहले डिस्कस किया था लोकल एरिया नेटवर्क, मेट्रोपॉलिटन एरिया नेटवर्क। नेक्स्ट हम डिस्कस करेंगे व्हाट आर वाइड एरिया नेटवर्क्स। वाइड एरिया नेटवर्क्स जो कि हमारा पूरे which is spanned across very larger area, across countries, across many cities. So WANs have a large capacity connecting a large number of computers. WANs use telephone networks, cable systems, satellites, etc. for connection and transmission purpose, which are easily available. So WAN enables its users to share data and information over a large area and usually requires some modem. They require all of kind of network devices because they require many complex and expensive equipments to span a network across a very large area. We can see in the diagram that there are single building LAN. There are systems which are connected using a bus topology and a very simple kind of network. In multiple building LAN, we can see that there are multiple building LANs and they are connected to a single cable or single link of transmission. And different topologies are used in different buildings, in one bus topology, another mesh topology, ring topology and star topology. In wide area network, we can see that systems are connected across globe, and this communication system requires wireless medium and all kind of network devices. Again, we will discuss protocols. So protocols, they consist of set of rules that governs data communication. It determines that what is communicated, how it is communicated and where it is communicated. Protocols are responsible that they should be designed in a way that all of the parameters, all of the criteria of a network, they are achieved in the right format. And so topics which are included in network protocols, these are syntax, semantics and timing. That what is the syntax in which the protocol is written, what are the semantics, the different languages used to write protocols which can be understood by the compilers and interpreters used in computer programming. So what is covered in syntax? Syntax is the structure or format of the data, meaning the order in which they are presented. Syntax is the order, we can say the rules rules with which the data is presented. For example, a simple protocol might expect the first byte of the data to be the address of the sender, and second byte to be the address of the receiver, and reset of the stream to be the message itself. In computers, in any communication system, that at the ground level, at the physical level, data is a pattern of bits. It is a stream of bits. So we can decide that we can decide according to our rules that how that bits, that stream will be used to define different parameters and message in it. We can say that first few bits will decide that some information about the message, like how much what is the address of the sender, what is the address of the receiver. We can say the last bits will decide that what is the number, what is the sequence of this packet. So accordingly we can define rules, we can define the syntax. Next is semantics. That what are the semantics? It refers to the meaning of each section of the bits. That what is the meaning of every section of bits? What is the meaning of every is the meaning of the data itself? That example, does an address identify the route to be taken or the final destination of the message? Like we defined that in syntax, using syntax we draw a kind of schema that what will be the pattern of different bits, different streams, different packets at different layers of the communication. And at semantic level we define that what is exactly in those streams of bits. Timing, that when data should be sent, it is also defined in the protocol that how fast that it can be sent. So example, if a sender produces data at 100 Mbps but the receiver can process data at only 1 Mbps, there is a speed mismatch between sender and receiver. Transmission will overload the receiver and data will be largely lost. So we have to decide according to that what will be the flow of the message from the sender side, so that it cannot be lost at the receiver side. So routing is that how the packet will decide what route the packet will follow across the network, so that it can reach from one sender to another receiver. Between a sender and a receiver there is a complex network in between. There is a complex connection of so many, if we consider a wireless wide area network, there are thousands of systems between one sender and one receiver. So there are devices which at packet level decide that what route the next packet has to follow. At every stage, wherever a router is located in the system, it decides, it creates the path of the packet to be followed at next end. So what is packet? Packet is collection of binary digits including message data and control characters for formatting and transmitting, and it is sent from one computer to another computer of a network. So we can simply say that when our data is fragmented at every step, we can call every fragment a packet. What is routing? So process of deciding which path data takes, which path the packet will take, it is called routing. And decisions are made using routing table. Routers are devices which have some routing table. Routing table defines that what path should be the most efficient path for the incoming packet, and then it will route that packet according to that path. And there are centralized routing and distributed routing. So routers, these are network connecting devices containing softwares of routing tables, connects networks through network systems and control traffic flow between them. Obviously when routers are used to define the path of packets, so they decide that which packet will go at which path. So they are controlling the flow of the communication in the system, and they must use a common routing protocol. Obviously router will also have a kind of protocol according to which rules it will, according to which algorithm it will calculate the path of an incoming packet. And in between we can have from a sender and in between a sender and a receiver we can have different so many routers also. So if they are following different protocol, it will become difficult for very cumbersome to for a communication system for a packet to follow same kind of path. So they should have same or synced protocol so that they define a proper and right flow of path of a packet. And router operates at network layer and it performs the same functions as a bridge. It is more sophisticated device and chooses the best possible path for packets. There are different algorithms which can be run to achieve best route for a packet at router. Next is client server model. Every communication in a communication system, it follows client server model. We can say a system sends a request to another system to get some message, or a system sends a message to another system. So the system which is sending the message is the client, and there is a server which processes that request and sends the response back to the sender. So software runs on the local computer. It is the client system. The client is the software which runs on the local system, and server is the software which runs on the server. So communicates with the remote server to request information or services. Server, remote computer on the network that provides information or services in response to client request. So there is a remote location, there is a server which processes client request and accordingly gives the response. So there is advantage of scalability and it's network devices. Now we will discuss what kind of devices are available in a communication system. Intermediate devices. So physical devices that allow hardware on a computer network to communicate and interchange messages from one point to another. As we can see in the diagram, there are different LANs and there is different routers in between them marked with pink circles, and in switched bands there are different devices which connect to the modem and then to the WAN, to the wide area network. So routers they decide that what path the packet would follow to go to the next LAN or next WAN, whatever. Repeaters. So as we discussed that there can be attenuation in the signal, that signal loses its power while propagating. So repeaters are used to regenerate that power during the transmission. So repeater is a network device used to regenerate a signal. Repeaters regenerate analog or digital signals that are distorted by transmission loss due to attenuation. So a repeater does not make an intelligent decision concerning forwarded packet. It just repeats the signal. It does not apply any algorithm, any decision making thing on that signal. It is just repeating that signal. Hubs concentrate on connections. In other words, they take a group of hosts and allow the network to see them as a single unit. These are done passively without any other effect on the data transmission. Active hubs concentrate hosts and also regenerate signals. So hubs are there which also they have different ports. They receive signal from one port and send signal on another port, or either they broadcast the signal. They are just forwarding the signals from one port to another port. Switches add more intelligence to data transfer management. Like switches, they can determine if data should remain on a LAN and transfer data only to the connection that needs it. Another difference between a bridge and a switch is that a switch does not convert data transmission formats. Hub does not have any intelligence. Switches have some intelligence to determine that whether the packet will be transferred to another connection or not. Next are bridges. Bridges convert network data format and perform basic data transmission management. Bridges provide connections between LANs. They also check data to determine if it should cross the bridge. This makes each part of the network more efficient. You can see in the diagram, hubs are there, and between hubs, between different LANs, there are bridges in between. They are also operated at data link layer. Routers, we have discussed already that routers have all the capabilities listed above. Routers can generate regenerate signals, they can concentrate multiple connections, they can convert data transmission formats which switches cannot, and they can also manage data transfers. They can also connect to a WAN which allows them to connect LANs that are separated by great distances. What are gateways? Gateways are used to gateways are a bridge on different kind of networks. We have one network which is of different kind, and there is a gateway, that's why it is named as gateway, and we can go to a completely different kind of network. So gateway kind of exchange of protocols. Some network has different protocol and another network has different protocols. In between we have gateway. So gateway is a piece of networking hardware used in telecommunications that allows data to flow from one discrete network, one different network, to another network. Gateways are distinct from routers or switches in that they communicate using more than one protocol to connect a bunch of networks. So when networks are different, they are discrete, they are using different protocols. So if we have a device in between them, gateway, so gateway has to understand different kind of protocols, different kind of conversion data transmission formats, so that it can create a communication, it can fill the communication gap between different networks. Next we will discuss OSI model of communication. OSI model defines the communication process into several layers. In any communication network, the tasks are broken into subtasks at different layers, and these are different tasks implemented at every layer in a stack. So we can see this for a simple message transmission using through a postman. We can, when we send a letter from to another individual, we will first write the letter, then we will pack it in an envelope, we will send it to deliver to the courier by post office. Then post office of the receiver's area will receive the packet. The letter is carried from the post office to the mailbox, and then from mailbox it is received by the receiver. So there is a set of process that there are different kind of process, and we can say different kind of layers which are operated at receiver's end and at sender's end. So same kind of process happens in data communication also. These are divided into 7 layers. Divided into 7 layers at both the ends. Application layer is the layer where we have application data, the software data we have. At presentation layer, it performs some functions. Then session layer, transport layer, network layer, data link layer, and physical layer is the layer where we can say the signal is flowing through the transmission medium. So communication must move downward through the layers on the sending device and over the communication channel upward to the receiving side. So each layer in the sending device adds its own functionality, own information to the message. It receives from the layer just above it and passes the whole package to the layer just below it. So at every layer there are functions defined of every layer, and at sender side they add a header, we can say header or information at every layer, and in same manner it is truncated from at receiver end to receive message of that layer. So at the receiving side, the message is unwrapped layer by layer, with each process receiving and removing the data meant for it. So we can see that what are the functionalities of different layers. At application layer, there is allow access to network resources. At presentation, it performs a function of encryption, compressing data, translation of data. Session layer is responsible for terminating and starting session between two systems. Transport layer is responsible for the process to process delivery, that when the two systems are communicated, so there is one process, there are multiple processes running at one side. So one process is sending the message to one process of the receiver. So that process to process delivery is the responsibility of transport layer, and source to destination, this responsibility is of network layer. So network layer is to send the message from right source to right destination. And data link layer it is responsible for hop to hop delivery. Hop to hop means between sender and receiver there are different nodes in between. So data link layer responsibility is that from this node the next node should be A, B or C. From C, what should be the next node? So this hop to hop delivery is the responsibility of data link layer, and at physical layer it is to transmit over a medium. So we have to transmit the signal. Physical layer has the responsibility of transmitting the signal at physical medium. So next we can see an interaction between the layers in the OSI model. So device A is the sender, device B is the receiver. The message from application layer goes to the physical layer, and in between it goes to the network layer. In intermediate devices it goes to the network layer. As we saw earlier, at network layer router devices are placed, and router devices decide that which path does the packet has to follow. So accordingly, at only destination side it will go above the network layer. The packet will reach above the network layer because it is the destined host, destined receiver of the message. Otherwise the packet is routed to next node in the path. In exchange in the OSI model, we can see at 7th layer, that is application layer, data is some information like H7 is added to the data, and it is passed to the next layer D6. Some information H6 is added by layer 6, then to that data some information is added by layer 5, and subsequently till physical layer some information is added. So apart from data, we have particular messages, particular information of every layer. So that has to be removed at receiver layer, so that finally the receiver could extract the message from the received packet. What is the exactly message? So in this way communication happens at both the layers. So this was the OSI layer, and what we can recap that what we discussed in this. We discussed that what is the communication, what are the different network devices, what are different topologies, different categories of networks. So this was all about data communication and networks. We will discuss more of it in subsequent classes. Thank you.